Welcome to the Head Shepherd podcast. I'm your host, Mark Ferguson, CEO here at NextGen Agri International, where we help livestock managers get the best out of their stock. Before we get started, thank you to our two fantastic sponsors for continuing to sponsor this podcast. MSD Animal Health is perhaps better known as Cooper's Animal Health in Australia and for their Allflex range across the world, with a comprehensive suite of animal health and management products. Honiger is a one-stop shop for wool harvesting and animal fibre removal. The Honiger team have a deep understanding of livestock agriculture, backed by Swiss engineering and a family business dedicated to manufacturing the best. We are grateful to our sponsors for their support, helping us bring Head Shepherd to you each week. And now it's time to get on with this week's episode. Welcome back to Head Shepherd. You're with Ferg. Great to have you listening along. This week we're talking Toxoplasma and Toxoplasmosis, which is what we would often see and can see in abortive storms in sheep, which causes a fair bit of grief around the place from time to time. As we know, it's passed through cats, or cats are part of the life cycle of Toxoplasma. And what I didn't know and what we learned during this episode is the impact of surface water on sheep being exposed to toxo. And I guess it makes sense that obviously spread through cat feces, and therefore if it's all washed into a dam from a big area, you can get those oocysts concentrating in those dam water and therefore be exposing the animals to it. What I learned during this episode is it's a tough little beast and really hard to kill. Other than getting it sort of above 65 degrees, it's pretty bomb-proof. So it makes sense as to why it can sort of stay in the environment and cause a bit of grief. But yeah, the stat that an animal that's exclusively getting its water from surface water or dams is 10 times more likely to be exposed to toxo than the one that's getting its water from a trough or from a reticulated water system is a pretty big impact, and something we chatted about after the show. And so yeah, good to have that stat in your mind, that 10 times number of if the animal's only getting water from dams, it'll be 10 times more likely to be exposed to toxo. Obviously, we've got vaccination opportunity in New Zealand, but not currently in Australia. So yeah, ways to manage that disease are sort of brought up during this episode, and I think you'll enjoy it. We don't often think we'd sitting around talking about Toxoplasma and think it'd be fun, but I actually really enjoyed this conversation with Connor from Adelaide Uni. Before we get into that show, just quickly mention an article that I've written this week. I'm actually back on the keyboard, and so it's available on the Hub or linked to it on the Hub. And at this time I've tackled kind of the disappearing use of heterosis. I was having a conversation the other day with Jason Archer from Beef and Lamb New Zealand, just talking about Triple ABG coming up, which is a conference in Queenstown, a genetics conference. And we're sort of talking about how, I guess, with big premiums for Angus cattle, we're seeing what is a great opportunity, which in hybrid vigour sort of seemingly disappear, or at least be reduced in the cattle industry. So I sort of wrote an article about that. It kind of morphed into an article around using breeds as a kind of proxy for quality and the risks that are associated with that. Not having a crack at Angus or anyone else really, but in some parts of the world we've got merinos at a discount, others we've got them as a premium. Angus have a general premium across lots of markets, and yeah, I guess this article just explores when to use hybrid vigour, and I guess the power of this new world that we're entering into, where carcasses are valued based on their likely eating quality and lean meat yield and all the things that actually do matter to the productivity of that system, rather than just coat colour or the breed that we've assigned to it. So yeah, I guess a bit of a plea to rethink some of the ways the market's going about how we're valuing animals, but not sure it'll have any great impact, but enjoyed writing it just the same. Righto, we'll get on with this week's show with Connor Bury from Adelaide University, talking Toxoplasma and Toxoplasmosis. Welcome to Head Shepherd, Connor Bury.
Thank you for having me.
Great, mate. Thank you for taking the time out today to share your wisdom on Toxoplasmosis, which causes a bit of grief for not just Australian sheep farmers, but around the world. And so before we get into that, it'd be good just to get your background, how you ended up with an interest in abortive diseases in sheep.
Yeah, fair enough. That's a good question to ask. So I've started my career as a veterinary parasitologist, and I suppose that journey started when I was doing my honours project. I was exploring the epidemiology of Toxoplasma in sheep, and I've continued to pursue that, and currently working as a research officer with a group that focuses on Toxoplasma as well as some other parasites that are closely related.
Cool. So we'll get to They are, because it's not going to take me long to get out of my depth on this topic. So, but that's why we've got you to chat about it, not me. Before being a veterinary parasitologist, what, you grew up on a farm or out of town, or how did that look?
Completely opposite for me. So I've always wanted to work with animals, but very much from an urban sort of area growing up.
Yeah.
And I suppose, the question I was always asked when I'm, studying at university was, which animals are you going to work with? What are you going to focus on? And for me, I learnt about parasites pretty early on, and that, I became very interested in that. And that allowed me to, rather than focus on a particular, livestock or companion animals, wildlife, pursue the parasites that takes you across the entire spectrum of animals.
Cool. So work on small animals. Excellent. So you're there at University of Adelaide, when there's plenty of good people working out of that institution in agriculture and across a range of fronts. I guess if we start sort of talking about Toxoplasma, is it Gondii or Gondii? How do you say that?
Gondii,
yeah. So Toxoplasma Gondii, or toxo, that most people would talk about. Why is it a disease of significance for the sheep industry?
Well, the long and short of it is that it's a cat parasite that is spread to livestock, and the significance is it causes reproductive failure.
Yeah, and so that's when people will most likely see it. So we've all seen, or most of us seen, some versions of abortion storms. What state or what stage of pregnancy is the main impact of toxo?
So the stage of gestation that the exposure occurs is really the driving factor in terms of the outcome. In terms of reproductive loss, if it occurs early in gestation, you often see animals that resorb their fetus. So you'll have animals that scan as pregnant, and then if you scan them again, they'll be dry, and they obviously won't carry a lamb to term. If it happens during the middle stage of gestation, that's when we see abortions, and of course you mentioned abortion storms as well. So when these things strike, it's generally quite spectacular and can be all at once.
And so it's spreading from feline, which includes foxes. Is that right?
No, so just cats. So in Australia, feral cats are a great concern in terms of contaminating the environment. I suppose when we talk about Toxoplasma in relation to sheep, there are three components of Toxoplasma that are really relevant. The first is the oocyst. So this is the stage that is shed by the cat, and the cat's the only animal that will shed this stage. So they're highly resistant in the environment. Once they're out there, they're going to stay infectious for over a year, maybe longer. And cats are shedding a great volume of these once they're infected. So they'll shed these oocysts for about 10 days, but at the peak of that shedding period, they're shedding up to 100 million of these per day. And it doesn't take very many to drive an infection in an intermediate host, which would be a sheep in this case.
And then how does that life cycle complete itself?
So sheep are the intermediate hosts. The next stage that's probably important to talk about is the fast-growing stage. So once a sheep is exposed to one of these oocysts, in the intestinal tract, the fast-growing stage starts to proliferate, and it spreads throughout the body. So Toxoplasma is one of the parasites that is it has to invade a cell to complete its life cycle. So they invade cells, they start to rapidly multiply inside, and they cause damage because they destroy the cell when they are releasing. So they really fill up these cells and they burst the cell and move on to the next one. So it starts in the intestinal tract, but it migrates throughout the body of the sheep, through the blood, through the lymphatics. In terms of the reproductive outcome, if we have this active infection whilst the animal is gestating, this rapidly growing stage will cross the placenta and will start to destroy the fetal tissue.
And that doesn't sound like a lot of fun for the sheep either. Is that an illness that we would see? Like in an adult animal, obviously it's impacting them, but I haven't heard of what that looks like in terms of an animal being unwell.
So in terms of clinical toxoplasmosis, so the disease that's caused by Toxoplasma, it's mostly associated with neonatal animals or the immunocompromised. So the next stage of the life cycle that's really important is the dormant and slow growing stage. So once those rapidly growing stages have spread throughout the body, the immune system of the host starts to kick in and starts to remove them. And Toxoplasma, in response to this, those parasites that are currently still within cells, they slow down and they form tissue cysts. And this is why once an animal is infected, you've got this source of toxoplasma within the tissue of the animal itself. So in terms of sheep, it's also a public health risk because we have sheep meat that is contaminated with Toxoplasmosis, which can infect people if you consume undercooked meat.
Yeah, right. It's quite a nasty little beast. And then obviously a cat needs to eat a dead animal to go around again. Is that how that completes?
That's right. So in an ideal world for the parasite, it is inside a cat. It gets shed out in the feces. It contaminates the environment, and something like a mouse comes along and is exposed. Parasite goes through its life cycle in the mouse. The mouse ends up with tissue cysts in its muscle, in its brain, in other visceral organs, and the cat then consumes that. Toxoplasma is incredibly successful, though, in the amount of sort of intermediate host that it's able to infect. Essentially, any warm-blooded animal, it's capable of forming those tissue cysts inside.
Yeah, right. Excellent. So it seems like something that's going to survive a nuclear holocaust. So that's good to know.
Yeah, it's pretty much bomb-proof. Yeah.
Yeah. You've been studying this beastie and looking at, I guess, how many flocks are around South Australia, particularly where your home state are impacted, and there's a pretty alarming sort of level of infection rates out there in sheep.
Absolutely. Yeah. So it varies by property, and there are on-farm factors that can contribute to the exposure. But in general, across South Australia, we're looking at numbers of between 30 to 40% of sheep on farms test positive to a serological test. So the term that gets thrown around is seroprevalence. When we see that term, what we're talking about is detection of antibodies specific to toxoplasma in that animal. And that doesn't indicate that they're currently unwell. It just means that at some stage in their life, they've been exposed and they've developed an immune response to that parasite.
Yeah, right. And so 30 to 40% of animals, so that means most farms are going to have prevalence, seroprevalence, if we get fancy.
Just about every farm. So we see flock level seroprevalence of 100%. So at least one animal on every property is going to be exposed in some way.
Yeah, right. Excellent. Is that common? Would that be every state in Australia and New Zealand? That'd be like it's South Australia is nothing particular about South Australia that would make it more likely to be prevalent there?
Anywhere that has cats, which is the vast majority of locations, yes, there's the capability for that parasite to be spread. You do see higher exposure rates, essentially, where cats are more abundant. So one of the focal areas for me has been Kangaroo Island. The relative feral cat abundance on Kangaroo Island is about 10 times greater than it is on the mainland. And this is a trend that's seen on most small islands. So in that particular case, you're going to see a far more substantial exposure in livestock in those locations.
So some of these farms, I guess, would be quite extensive and might not often see a feral cat, but there's obviously enough. Is that just feces in, obviously just around the place? Like it's not, I mean, the old story was sort of cats in the hay shed or whatever, but a lot of these people wouldn't be feeding hay, so it's just general cats in the environment.
That's absolutely right. So we've looked at things like the rate at which cats are spotted on a property, so looking to gauge, the amount of cats and potential interaction with livestock, but of course, cat access to feed and things like that. And it's not generally all that well associated with exposure. What we tend to see is that areas where surface water is able to run off into drinking water, we see a really strong association between that particular phenomenon and exposure in sheep. Right.
So that's a big catchment with a dam filling into a dam, and then that being like obviously access by stock water, and that's the big that would be your primary or one of your risk factors.
Absolutely, yeah. So the really clear trend is that properties that have more surface water accessible to animals in comparison to reticulated mains water, we see a very strong increase in toxoplasma exposure amongst their animals. And of course, they're the properties that are also struggling with reproductive consequences in their stock.
Yeah, right. Is it just one exposure? Like, so if an animal gets infected through gestation some period and then might abort that lamb if it's is likely to, is it then immune for the next gestation, or can it get reinfected and the same outcome?
For the most part, generally, yes. So it's quite unusual to see repeated abortion. So if that animal, and the same thing, if that ewe has been exposed long prior to gestation, then you're unlikely to see the same sort of outcome that you would if it was exposed during that sort of critical period.
Yeah, right. Beyond that surface water, is there other on-farm risk factors that you sort of picked up that a producer might be able to use to assess their own level of risk?
Surface water is the big one. Again, it's clustered by property, and you can be unlucky, I suppose, in terms of the interaction between cats and your livestock. Surface water, but surface water runoff as well. So we're getting, large areas of contamination potentially with oocysts. If you have lots of cats, it might be that they contaminate the pasture as well. So that would be another factor. But in terms of properties that have high rates of exposure, sometimes you may not see all that many cats, and there may not need to be that many physically on the pasture, but you have this surface water runoff that concentrates the oocysts, then you've got this reservoir of the infection for your stock.
Yeah. And they're obviously, as you've mentioned, are bomb-proof, so they can sit in that water for a year and be infective, or however long it...
Absolutely, yeah. So when the oocysts are first shed, they're not infectious. They have to develop in the environment for a couple of days. Once they have achieved that, in fresh water, they can last 12 months, 18 months, even longer potentially.
Yeah, right. Does chlorination or any other water treatment kill them, or are they...
They're very resistant to sort of conventional disinfection. So these oocysts, their job is they form this protective layer around the infectious component, and they're very difficult to get rid of.
Yeah, right. Sound great. If we talk about economic impact, and that I imagine is a little bit hard to quantify because it can be hit and miss and can be a massive impact and then maybe less so in other years. But yeah, you would have studied the sort of level of impact it has on flocks?
Yeah, absolutely. So the relationship between seroprevalence and lamb marking has been modelled. And essentially, we see for every 10% increase in exposure rate, about a 5.5% decrease in lamb marking numbers. 10%
increase in exposure rate equals 5.5% reduction in lamb marking area. And so what is...
That's correct.
So that's... I've used testing serologically that they're being... testing positive to having had the disease at some point. So that number, if you multiply that, then you end up with, so for every 10% increase that, you get 5.5% decrease in lambs.
That's right. So that's a general trend. So that's not necessarily that those 10% of the exposed animals have to be exposed during gestation. That's across the entire flock. If you have a 10% increase, you're looking at a 5.5% decrease in lamb marking.
Yeah, right. So very significant considering our average is 40% or whatever it was.
Absolutely.
30 to 40. Yeah. So up to, averaging quite a large number in terms of losses. So a significant battle. What, I guess, can be done to prevent/manage toxoplasmosis on a typical farm? There's obviously water, that water one, and minimising access to surface water, which may or may not be possible. But yeah, I guess what are the things that you would typically suggest farmers do differently than they currently do?
Yeah, that's a really good question. Again, Toxoplasma it's an interesting parasite, and it's probably not the first one that we think about when we think sheep parasites. So we can't really manage it in the same way that we would worms or lice or something like that. So probably important to point out that in comparison to those nematodes, we don't have sheep shedding any infectious stage into the environment. So we don't have sheep contaminating pasture, for example, in that case, and we can't manage it with drenching or anything like that. So if we want to protect stock from reproductive consequences, it's really that period from joining to lambing that we're looking at. So you're right, in terms of changing your whole watering management system on a property, it varies from property to property, but that's not always very feasible. Yeah. At the very least, if you can increase the amount of reticulated mains water that you're supplying to those animals during that period, then that's going to go probably, in terms of what we can do, the furthest to mitigate the risk of exposure and reproductive loss.
If you are someone if you test your sheep and you're sitting at 40%, that's a 20-odd% reduction in lamb marking. So you could invest a fair bit of money in reticulated water to pick up a 20% lift in reproductive.
That's output. It. I think if you're really struggling, it's probably very worthwhile. And so 30 to 40%, that's the average in South Australia.
Yeah.
We've seen properties that are well in excess of 70%. Even properties that, one in particular, I recall that of those sampled animals, we were looking at 100% exposure. So certainly it may be in your best interest in particular cases to invest in fencing off some of those surface water sources. Because one other thing that can occur is that the parasite, once they're in the surface water, they will settle and they'll sort of sediment down the bottom there. And drinking behavior from livestock will disturb those settled oocysts, and they'll resuspend in the water and then be accessible. So it may not necessarily be the case of completely eliminating surface water, but if you can not allow stock to disturb that water and then potentially pump it to a trough or something like this, that might go a good way as well to putting you in a good position.
Yeah, I guess your typical dam with a float, you're taking water off the top, which isn't where they're going to be after they've settled out. So you could...
That's right.
So you could definitely influence that outcome. Yeah, intriguing stuff. I know in New Zealand we've got a vaccine for toxo. That's not available in Australia, is it?
No, it's not. So the Toxovax, the vaccine that's used in New Zealand, it's the live vaccine. So there are all sorts of biosecurity impediments to bringing it into Australia. So obviously, look, a vaccine would be ideal. That would, and if you can provide protection again around that critical period, you don't have to necessarily immunize the animal for life. But if you can immunize it and provide protection during that period where they haven't been exposed and they're going to gestate, that would be an excellent option, of course.
Yeah. And is there any light at the end of the tunnel in terms of that being available in Australia, or that's not on the cards?
I certainly hope so, Mark, because I'm currently involved in a big vaccine trial, and that's exactly what we're doing at the moment. So we've got animals that we've vaccinated, they've been joined, pregnancy scanned, and we're very hopeful that our vaccine material is going to provide protection from abortion.
Yeah, right. Cool. And so that's probably our biggest hope. And obviously for our Kiwi listeners, they've already got a solution. Whether they're using it or not will be up. This will be just as relevant to them because some people won't be using it and might be suffering some significant losses without knowing it. But yeah, I guess if it is becoming available in Australia, then that's going to certainly make life a lot easier for those places that are really significantly impacted.
Absolutely.
I probably know the answer to this, but I'm assuming trapping cats, like shooting cats, reducing cat numbers, that sort of, you can't have a big enough impact to have an outcome, or is there a bit of hope doing that?
I think, look, any reduction in feral cat numbers is a good reduction. Toxoplasma is only obviously one of the many ways that they exert pressures on many ecosystems. Cats are very hard to get rid of. There are many examples of good efforts being made to reduce numbers, and unfortunately, what we see is that a cat, when it's first exposed to Toxoplasma, will shed oocysts and contaminate the environment, and that will last from a week to 10 days. And then any subsequent exposure after that, we're not going to see any, or not very much at least, oocyst shedding. So the estimation is that about 1% of all cats worldwide are presently shedding oocysts.
Yeah, right.
That's not a great proportion there. And if you're skimming off, let's say you make an awesome effort and get rid of 70% of feral cats, and you're looking at, cats of a couple years old, you're potentially not making all that much of an impact to the amount of environmental contamination with those infectious oocysts.
Yeah, right. Yeah, right. Yeah.
It's generally when the cat first starts to consume live prey, that 30% exposure rate in sheep, that sort of holds true for a great many intermediate hosts, including people. And if a young juvenile cat in its first, second, third live feed consumes an exposed animal, then bang, you're going to get this massive shedding of oocysts.
And so it is just the fact that they shed massive numbers and they're bomb-proof that so they just hang around the environment for so long, because it seems like on those stats you think it would disappear, but obviously it doesn't. So
that's it. Massive numbers, they're incredibly resistant, and it doesn't require all that many to produce an infection. So it's a trifecta that's very difficult to overcome. Yeah.
If we do talk humans for a second, what is toxoplasmosis in a human population? Like, if we eat undercooked sheep meat, what happens to us?
Again, another good question. So that 30% exposure rate, that holds true worldwide for humans as well. So we're looking at, in general, about 1/3 of the human population has already been exposed. And we think about, there's exposure to oocysts, which could be in water, in food. It could be outside as well, depending on, how unlucky you are. In terms of undercooked meat, so cooking meat to 67 degrees will inactivate those cysts, and you'll be perfectly fine in that case. So it's not all exposed meat. Figures on lamb meat are interesting. There have been some studies that have shown that up to sort of 43% of lamb mincemeat products test positive to Toxoplasma DNA. So at the very least, Toxoplasma has reached that particular animal. When we have a positive PCR test like that, it doesn't necessarily mean that there are viable tissue cysts in there, but it's a very good guiding number in the first place. So, yeah, it's very easy for humans to be exposed to this parasite.
And how crook does it make you? How bad is it for humans? Well, probably very bad if
it's a tricky question.
Pregnant, no doubt.
Yes, that's it. It's a tricky question to answer. So for pregnant people, absolutely, it can be a very big deal. It can cause reproductive failure in people as well. In immunocompromised individuals, they can also suffer from clinical toxoplasmosis. So it can be a very substantial disease in those particular cases. There's more and more emerging work. So these tissue cysts that form, we've been talking about them in the context of skeletal muscle in livestock. They also travel throughout the body, including to the brain. Some people listening that have heard things about Toxoplasma before, it's often described as controlling the minds of mice and things like that. And there's some truth to those statements, including in people. There are some interesting studies into patterns of behavior and sort of neuropathologies that could be associated with the formation of Toxoplasma tissue cysts. So they may not be any outward clinical typical signs, but there's potentially something going on.
So you get more attracted to cats, or what happens?
That's one of them, yes.
I might check a couple of my family members, but and that is true that like mice get less able to avoid cats. Is that
less incentive to avoid cats. So it's not completely explained, but there's a compromise between vertical transmission in mice. So a pregnant mouse transmitting the rapidly growing stage to her pups, but also male mice. These rapidly growing stages, they can occur in the sperm as well. And we see relationships between the production of testosterone and things like this. So we get these jacked up male mice that aren't so imposed by cats. And I don't think it matters how much testosterone is flowing through a male mouse. I don't think it's going to win that fight.
Yeah, righto. Interesting stuff. Is there anything else on so obviously vaccine research going on, which is great to hear. Is there anything else, emerging technologies on the horizon that you're sort of working on, or that is being worked on?
The vaccine's probably the big one, and that probably has the most relevance to being able to maybe commercialize and provide to producers. There are always chemotherapies looked at, so drugs that potentially might also be able to help. But I suppose that the main effort at the moment is in better understanding, first of all, what on-farm factors contribute, and then what we can help to mitigate in that case, and a combination of also providing a vaccine to reduce the reproductive consequences. Yeah.
And just quickly, when you're in the heat of a storm, there's nothing you can do pretty much. Like if you've, like the first one, you notice the first abortion and you get it and you work out that it was, or A, how do you work out it was Toxoplasma? And then B, is there anything you can do about it?
That's it. So it's very difficult to know until you have a big problem on your hands. Once a sheep is exposed during pregnancy, we see abortions occur sort of 8 to 10 days after that exposure. So it's a very quick turnaround. You may not see any outward signs before that, and then bang, you've got fetuses being aborted.
Yeah.
The same thing in terms of treatment. Anything that is that you can first of all note that treatment is required and then actually roll out. It's just not a very good combination in this case. So there are some drugs that have been shown to be somewhat effective, but in terms of practically applying that in numbers, I don't think it's going to be a very good option, and it hasn't proven to be a good option.
And so if there's a farmer sitting, listening and wondering, are they a 20% farm or are they an 80% farm, is there a way that they can sort of find that out?
Well, absolutely. I suppose if you're if your landmarking numbers aren't looking as good as you might expect them to, or if you have particular blips, you have certain years where you're thinking I'm down, a significant amount, you can absolutely have a look at your flock. So it's just a very simple blood test we just take blood from the sheep, run a serological test, and you can sort of explore the rates of exposure in your flock. And that will give you a really good starting point of, is Toxoplasma to blame? Obviously, it's not the only pathogenic agent that causes abortion in small stock, but it could be the important one that's on your property.
And how many ewes would you typically need to test to sort of get a good handle on your proportion?
It sort of depends how many ewes are on the property. But look, as many as is feasible, it will give you the better picture. In my experience, sort of 50 to 100, something like that, is a pretty good number to give you a good representation from your flock.
And that's something you could organise through your vet if you wanted to?
Absolutely, yeah.
Yeah, cool. And I imagine, anyway, we won't get into that detail because it is irrelevant, but it's something that's certainly an option. And again, whatever that test costs, 50 times whatever it is, but it would help. It wouldn't be many lambs you'd have to keep alive to pay for that, I imagine. You mentioned at the start of this interview about sort of other parasites you're looking at. What other things are of interest out there that you're sort of investigating?
So most of my work, besides the diagnostic work, has been around parasites known as apicomplexans, and they are known as obligate intracellular parasites. So rather than things like worms that are living in the lumen of the intestinal tract, these are all parasites that invade cells. So Toxoplasma is one, Cryptosporidium is another. Coccidia in general. So at the moment, also working on a project that's looking at Eimeria in chickens, and so poultry production systems. And the group that I work with also focus on malaria parasites, so Plasmodium.
Yeah, right. Well, that's a discussion for another day. Coccidia is something that certainly interests those who are running indoor systems and running intensive system in sheep, where coccidia can cause all sorts of grief, but typically not as big of an issue on extensive farms that we work on. But yeah, interesting stuff. The last question we normally ask everybody, which I didn't give you prior, was what is the last thing you changed your mind about?
Oh, okay. Last thing I changed my mind about. That's an interesting one. Well, look, it's been instantaneous because I'm sitting here thinking, what have I changed my mind about? And do I try and work my way through that answer? No, I'm going to give you a philosophical answer instead. So I would say, look, the last thing I changed my mind about is probably far more recent than I would think it is. It's probably happened in the last hour or two. But I think, scientifically in particular, it's very important to be able to change one's mind. What's the last thing you changed your mind about?
Yeah, I'm not very good at answering that question, but
that's probably why you ask it. It's a good one.
Yeah. And it's not very fair to do it at short notice, but yeah, I think it's we like to ask it just to get people to, because as you've stated, really, that it's kind of if you're doing anything really in biological systems, you kind of need to be ready to change your mind because we learn new things and everything, like everything can change or doesn't always change 180, but we're always tweaking our knowledge, and I think that's pretty important in ag to keep our minds open and not get closed off to old paradigms. And so yeah, that's kind of the reason we ask it. And I stole it from a smarter person than me. It's not my question, but it is a good one.
Well, would you give me secondhand permission to steal that as well? Because I like that question. It's I'm a fan.
Yeah, it's I'm trying to think who it was. It's the author of the Diary of a CEO was where I stole it from. So
okay.
Whose name escapes me right now, Stephen somebody. But yeah, anyway, thanks, Connor. Thanks very much for your time today. That's been a really fascinating chat. I genuinely didn't think I would be this fascinated by Toxoplasma, but it has been really interesting to have a chat and to learn more about it. And I think, well, certainly for me, I haven't heard that surface water thing before, and that makes a whole lot of sense. So that's something that people could definitely integrate into systems if you're under challenge from toxo, and all the best for the vaccine research. I think that's clearly going to have a big impact on the industry with the sort of losses that you've already identified.
Thank you very much. Thank you for having me.
Thanks, mate. All the best. Thanks again to Heineken, who are proud world leaders in the manufacturing and supply of professional sheep shearing and clipping equipment. Thank you to MNSD Animal Health and Norflex Livestock Intelligence. They offer an extensive livestock product portfolio focused on animal health management, all backed up by exceptional service. We thank both of these companies for their ongoing support of the Head Shepherd podcast.